Let's start with HTTP handlers. As I mentioned, an HTTP handler is a .NET class with code that executes whenever a client makes a request for a file at a certain path. It's important to understand that this doesn't need to be a physical file and path, but can be a virtual file that triggers your application to perform some action to retrieve the requested resource. What's interesting here is that this is the way that ASP.NET works at its core. For example, when you request an ASP.NET Web Forms page, the page class executes. This is actually an HTTP handler because it implements the iHTTP handler interface and takes care of generating the response to the browser. There are other HTTP handlers built into ASP.NET, such as the trace handler class, which displays trace information when you request the trace.axd page, and forbidden handler, which displays an access forbidden message if a user attempts to request things like web.config and source code files from the server. ASP.NET is very simply built on HTTP handlers. You can build your own custom HTTP handler and install it right next to those provided out of the box with ASP.NET. The sample application that I'm going to show you shortly uses an HTTP handler that retrieves an image from a database based on a record ID without requiring that the image be a physical file on the server. You could also do things like create a handler that provides an RSS feed which updates from your website. I've even seen a handler implementation that automatically adds a copyright watermark to all images displayed on the website in order to protect the site's intellectual property. And there are many, many other options. There are two broad ways to create an HTTP handler. The first is to create what's called a generic handler, which means that you invoke the handler by requesting a virtual file with a .ashx extension. Whenever you request the file, your custom generic handler executes and handles the request. You can think of a generic handler as a lightweight ASP.NET page that contains a single method that renders some kind of content to the browser. The biggest limitation of a generic handler is that you can't map it to a path that doesn't include the .ashx extension. So, although this technique is a bit simpler to implement and use, you can't use this technique, for example, to invoke the handler when someone requests either a .jpeg or GIF file, because those files use different extensions. Now, there are ways around that, but it's still a limitation of the HTTP handler. Another, more flexible way to create an HTTP handler is to create a class that implements the iHTTP handler interface and map it to the path or route that you want. This gives you the maximum amount of control with how you implement and use HTTP handlers in ASP.NET. And this is a technique that I use in the sample application. You can create both synchronous and asynchronous HTTP handlers. If you create a class that implements the iHTTP handler interface, for a synchronous handler, you'll need to implement a process request method and an isReusable property. This kind of handler executes immediately and blocks any other code execution until it completes. This is the simpler option, but it could have negative impacts on application performance if the handler has to perform any long-running actions. Or you can create an asynchronous handler using the iHTTP async handler interface. In this case, you implement a begin process request method that kicks off the work, and an end process request method when the work is completed to generate the response to send back to the client. You'll also need to implement the isReusable property. The advantage of an asynchronous handler is scalability. ASP.NET maintains a limited pool of threads it uses to service requests, and when it receives a request, it assigns a thread to handle that request. If ASP.NET runs out of available threads, it queues the request until a thread is available. And if the queue gets too big, it rejects new requests with an HTTP 503 response that the server is too busy. Not a good thing, no matter how lightly or heavily your site is used. The nice thing about asynchronous handlers is that ASP.NET releases the current thread back to the pool while the handler is doing its work, making that thread available to handle other requests. When the handler finishes its work, ASP.NET assigns another thread to the original request in order to create the response to the client, and then the handler can return whatever results it generates to the client. So this kind of asynchronous support can help increase scalability, and it may well be worth it at the cost of additional code complexity. All right, I've mentioned the isReusable property a couple of times, which is required as part of both the iHTTP handler and iHTTP async handler interfaces. This is a read-only Boolean property that you need to set to either true or false in the handler class. But what does true and false mean? Well, according to the ASP.NET documentation, the isReusable property indicates whether ASP.NET can put an instance of the handler class in a pool and reuse it to increase performance. The idea here is that instantiating a new class takes at least some time, and reusing an instance can save that time. And if you need to do a lot of intense work in the class's constructor, making a handler reusable can mean a big boost in performance. So if you set the property to true, ASP.NET will reuse the instance. If you set it to false, a new instance is created for each request. On the surface, it would seem like handlers that don't contain state information, that just perform some action and then are completely done, would be candidates for reusability. Alas, but that's not really the case. The reality is that most of the time it doesn't matter what value you set this property to. So most of the time, just set it to true in case it's used, and you'll get the best performance. But, kind of begs the question, what part of ASP.NET uses the value of this property? The property is only used when you implement a handler factory using the iHTTP handler factory object, which is a bit of an advanced technique that you'll probably not need to use very often. A handler factory dynamically determines which handler should be used for a specific request. Once it determines which handler to use, the factory can query the handler to see if it's reusable in order to service multiple requests. And this determines whether the factory grabs an existing instance from the pool or creates a new instance. This is a technique that you might consider using when the HTTP handler class for a given request is not uniquely identified, when you have to implement some logic to determine which handler to use. And for most applications, this isn't going to be an issue. And in fact, very few of the built-in ASP.NET handler factories check the isReusable property. So this reinforces the fact that you should spend zero time trying to figure out the optimal setting for isReusable, unless, of course, you're building a custom handler factory. Here's a sample application that I'll use to demonstrate both HTTP handlers and modules. I'll go ahead and run the application and show you what it does first. All right, so as you can see, there's different options here. Don't worry about this right now. I'm going to talk about that when I talk about HTTP modules. But I have a couple options here to view employees and view product categories. And this is information that is coming from the Northwind database. When I click on View Employees, okay, so there you can see I'm getting some information about the Northwind employees, and I'm displaying the name, the position, and the photo. And I do that for all of the Northwind employees. And as you can see, the resolution of the photos from the database isn't all that great, kind of grainy sort of pictures, but it is what it is within the database. If I view the source for the page, and scroll down to some of this data here, here's a typical image source, image tag. And notice the source. So it's looking for, in essence, as far as the browser is concerned, it's looking for an nwindimage.axt file, and it's passing in an employee ID number 3. And that what this is this is the handler, this invokes the handler, the image handler, that goes out, passes ID 3 to the Northwind employees table and retrieves that picture. Okay, so there are no physical images on disk anyplace that I'm reading. It's all handled through an HTTP handler. Okay, so if I go back to home, do the same basic thing for categories. And there we have all the categories along with the picture from the categories table. Okay, so that's what the application does. Oh, and by the way, this uses the same hwindimage.axd. So just passing in a different query string parameter. So let me view the source here. And this time, these images are passing in a category ID instead of an employee ID query string parameter. So that's how the server-side code within the handler is going to know whether to go to the employees or the categories table. Okay, simple application. Let's take a look at the code. First thing to look at is the home controller. Okay, so first of all, I have the base action methods. So these are just the basic index actions. And then I have some additional code that I'll talk about a little bit later within the About page. And then the Contact page. Okay, so nothing interesting there for handlers. All right, so here's the code for the employees and categories views. The application uses an entity framework model, obviously going against the Northwind database. So if we come back over here to Solution Explorer, we can look at models and Northwind. And there's that model. Okay. So it includes the entire database, but of course you can include just whatever tables that you want. Okay, so that makes the data access code really easy, because it's needing to get the information, obviously, about the employees and the categories from the database. And so then the action method employees just grabs all of the employees and uses that as the views model, and then does the same thing for the categories. So pretty simple kind of code. Nothing fancy here. Nothing yet is involved with our custom HTTP handler. All right, so let's take a look at those two views. So the first one I want to look at is employees. Nothing terribly interesting here, except for that image element. And what's interesting about it is the source attribute. So there you can see we have the nwinImage.axd, and then creating that query string parameter, and then just using the model item, just doing a for each through all of the items passed in the model, in order to get the employee ID. The important thing here is that this call to, again, what the browser thinks is a file, invokes the handler because the handler is mapped to this particular file name, nwinImage.axd. And as you'll see when we look at the handler code, it's going to look at the query string parameter that it gets, either an employee ID or category ID, in order to determine which table to hit to return the picture. Okay, and then category view is pretty much the same thing, just for completeness there. So it's going to loop through the model and construct this source attribute of the image tag, but now using category ID. Okay, it's the same sort of thing. Now things get more interesting. So let's go over here into Solution Explorer and into App Code and take a look at the image handler. So this is the actual code that implements the custom HTTP handler. Okay, so first thing is that has a custom name, image handler, and the convention is to use the handler suffix, but there's nothing magical about that name. What's important here is that it implements the iHTTP handler. And it could also implement the iHTTP async handler, but this particular handler is synchronous. What that means is the class has to implement the isReusable property and the process request method. Okay, so here's isReusable, and it's read-only and returns true. Okay, and again, the actual value here really doesn't matter because I'm not creating a handler factory. And then here's process request. What it gets here as a parameter is the HTTP context. And that gives it the ability to do things like extract that query string parameter. Again, either employee ID or category ID. So then it news up the DB object. This is the context object for that Northwind Entities Entity Framework model. And then it creates a byte array image variable. We need to work with the image as a byte array. Okay, so if the request has a parameter of employee ID, okay, so it has that query string parameter, so if that's not equal to null, then it goes out and grabs the image. Okay, so I want to make sure that the ID value is an integer, so I set it to a value of -1 initially. And then it attempts to parse that employee ID value and has an output parameter of ID. So this is what sets the ID value, which is the primary key, into, in this case, the employee table. All right, and then we get the result. If not result, so if result is false, then we just end the response immediately. Otherwise, if it successfully parsed that value, so it is an integer, then it goes out and uses the find method of that employee's collection, again using Entity Framework, in order to retrieve the employee with that ID value. And then it just assigns the value of the photo property to that image variable. Okay, then the next bit of code does the same exact thing for the category ID. So if that query string parameter is not null, it takes the exact same steps and assigns the value of the picture field. Again, it's called picture in categories, where it's called photo in employees, and assigns it to that image variable. Okay, so there's a lot of different ways to do this code. The end result is that the image variable contains a byte array of that JPEG image, either from employees or categories. Okay, so here's a little bit of weird code, probably the only non-standard sort of thing. So if image is not equal to null, then we have an image within that array. So we set the content type to a bitmap, and then add a header that essentially tells the browser not to cache the image. So we want to retrieve the image every time the handler is invoked. So here's the weird thing that I mentioned. The code needs to strip off the OLE object header, which is unfortunately an artifact because SQL Server's Northwind database was ported from Access those many, many years ago. Okay? Now, normally when you're working with just a byte array without the OLE header, then you can just use this kind of code to use the binary write method. But in this case, we have to strip off the first 78 bytes. And so I used the output stream and the write method in order to perform that calculation, because I want to write out just a portion of that byte array. Okay, in any event, the net result of either of these techniques, whether or not I need to strip off that header or not, is to write the image bytes out to the output stream. Okay, so that's all the code that you need to implement for what's really a pretty simple handler, admittedly, but it's doing something kind of cool. It's directly accessing the bytes of an image in order to display and directly output them to the response stream of the response to the browser. Okay, and again, this is invoked for each of those image elements within the page. Okay, so, but how does the handler get invoked? That's the last piece. What causes this to get invoked? Well, it needs to be mapped to a path. And probably unsurprisingly, you do that within web.config. So I'll come over here and web.config. And it's a way down. It's around, yeah, there it is. Ends up being line 59 in my current web.config. And so this is the mapping of that path. And I want to respond to all types of requests. And this is how this path gets mapped to that image handler. Okay, now there's a number of other ways to do this kind of mapping. You can do it in code. There's various other techniques you can use, but this is definitely the simplest way. You can also hook into the routing API, and there's a lot of flexibility with how you implement and use handlers. It's a great feature for going outside the box when you need to do something that ASP.NET or MVC wasn't directly designed to do, by hooking into the ASP.NET infrastructure directly. In general, it's better to use features that are built into ASP.NET and MVC directly, but if it just doesn't do what you need, or you need to do something really custom, then you can do handlers and it can solve a lot of kinds of problems. Now let's move on to HTTP modules. Despite the similarity of the names, HTTP handlers and modules are completely different things. Unlike an HTTP handler, which is a response to a request for a specific path in the application, an HTTP module is called on every request made to the application. Modules are part of the ASP.NET request pipeline and have access to the various lifecycle events that ASP.NET goes through in order to generate a response to a client request, and this includes MVC applications. There are two ways to respond to HTTP application events, which is ultimately what we're doing with modules. You can write code in the global.asax file or create a custom HTTP module. If the action that you'll take in response to an application event is anything beyond the trivial, it's almost always better to handle it using an HTTP module, putting it in its own class and keeping the global.asax file clean and simple. HTTP modules are also reusable. The sample I'm going to show you shortly is implemented in the same project that uses it, but you can put it in a class library and reuse it wherever you want. And you can even put it in the global assembly cache, or GAC, if that's appropriate, which is also something you can do with HTTP handlers. On the other hand, putting code in global.asax lets you instantiate global objects for use throughout an application. You can also write code for the session start and session end events, which aren't available for use with HTTP modules. So using HTTP modules or the global.asax file depend on what you need to do within the application and whether your code needs to be reusable across projects. Behind the scenes, ASP.NET uses HTTP modules to implement many standard framework features. It uses the Forms Authentication module to implement Forms Authentication, and the Windows Authentication module to implement Windows Authentication. It implements Session State with the Session State module, and Output Caching with the Output Cache module, and the list goes on and on and on. When a new ASP.NET application starts, it loads all of the HTTP modules configured for that application, and each of those modules subscribe to one or more HTTP application events. You can create your own custom HTTP modules by implementing the iHTTP module interface, which requires two methods, init and dispose. Init lets you subscribe to HTTP application events and define what you want to do in response to those events. And dispose, like other objects in .NET, lets you clean up any resources that you use in your module. Okay, let's take a look at the implementation of a custom HTTP module in the sample project. Here I am back in the Handler Modules sample application. I'm going to go ahead and run it again. And there's the home page for it. Okay, so now I'm going to talk about these boxes up here. These show the various times required for resources to load the page. And if you click on the various items, it'll show some information about loading the various resources. The interesting one is right here. Actually, no. There it is, okay. Yeah, so this is the information about the actual index view for the application. So it contains some statistics about the performance on the page. And you can include custom information if you instrument the code in the application. And you can also show time with various children. You can share the information. You can show trivial events and so forth. If I go here to view employees, notice that I have different kinds of information. What's behind all this is a really sweet tool called Mini Profiler. and it's available for free. It was developed by the folks who built Stack Exchange, which is a marvelous resource for getting technical questions answered, which is branched out to other non-technical areas as well. If you do any kind of Google search for technical questions, particularly programming questions, there's a pretty good chance right at the top of the Google results is Stack Exchange questions and answers. All right, so you can get information about the tool at miniprofiler.com. It has a lot of very cool features, of which I'm using only the most basic in the sample application, because it's really, what I'm talking about here really isn't Mini Profiler, but I'm using it as an avenue to talk about HTTP modules. Okay, so next what I'm going to do is run through how I implemented the Mini Profiler in the project. I don't want to dwell on it too much, because that's not really the topic at hand, but I need to give you enough information so that you get a feel for how it's used in the project, so that HTTP modules make sense. Okay, so I'll shut down the application here. And there's a few steps that you need to take to use the Mini Profiler. First, you have to install it in your project. Okay, that's made trivially simple by, once again, you probably guessed it, NuGet. So let me stop the application. And I can go into the GUI interface. And once again, my installed packages. And I'll search for Mini Profiler. All right, so those are the packages I have installed. And there's another one available for WCF applications as well. So this is the main Mini Profiler that you need to install. And then there's some additional features for integration with Entity Framework. And then I also needed to include the MVC 3 version, which also works with MVC 4, in order to get the hooks so that it understands the structure of an MVC 4 application. So the nice thing about this is that you don't have to install this first. You can go ahead and install this directly, and this will take care of installing any dependencies, including this core library here. Now I just installed this here. I'm not really hooking into the Entity Framework features, but if you want to profile Entity Framework as well, you can include that module. And as I mentioned, there's an additional package for WCF. Okay, so that's already installed within the application. Next thing you have to do is include the Mini Profiler CSS and JavaScript files in the views. And the easiest way to do that is with a render include statement in the layout page. So I'll go down here to shared section _ layout. And include the render includes right there. So makes it trivial easy to include the user interface stuff that Mini Profiler needs. That takes care of displaying those loading times in the upper corner, as well as the pop-up box when you click any of those times that I showed you. Okay, third thing you need to do, and I'm doing this in a little bit out of order in how you'd actually implement things, but I think you'll see why in a moment. So the third thing you have to do is instrument any code that you want to include any special information in the profiler output. So I didn't spend a lot of time doing that. I'm mostly using the basic features. But I did include a little bit here within the about action method. So I instantiate an instance of the Mini Profiler using the Mini Profiler current. And then using this profiler step, that's going to output some information about just essentially saying the message do complex stuff, and then indicating that we're doing step A here, sleeping for a second, or actually 100 milliseconds. But typically you're doing something interesting here in order to test things that you want to profile and be able to get information about how long that part of the about action method takes. And then doing something else here. So again, this is a very simple, almost trivial way of instrumenting your code, and you can do far more complex things. Okay, you do get page info profile information without doing this kind of instrumentation, but by instrumenting your code, you can significantly add to the information that the profiler captures. All right, then the last thing that you need to do is to start and stop the profiler in the HTTP application's begin request and end request methods. All right, so there, as you'd expect, is where the HTTP module comes into play. Now, one way to do that is to put that into the global.asax file. Okay? But as you can see, there's nothing here other than some of the standard stuff that you need to do for the startup of an MVC4 application. Because I actually took advantage of features that are built into Mini Profiler. All right, so where we can see that code is here within app start and this Mini Profiler file. And this file is actually added when you add Mini Profiler to a project. Okay, so this code file, code module, has some fairly complex code in it that, again, I'm not going to dwell on too much. But what's happening here is pretty straightforward. Ultimately, what all this code does is define an HTTP module to hook into the begin request and end request application events, along with some initialization code. Okay, so the code has three main features. First thing is that it has a couple of attributes on the custom assembly that this project is creating. And these define the pre-start and post-start methods that execute when the application starts and finishes startup. So this new web activator attribute lets you have code run way early in the ASP.NET pipeline as an application starts up. I mean, way, way early, even before application start that you can define within global.asax. This happens to also be before code in your app code folder, assuming you have any code there, has been compiled. And this web activator is part of ASP.NET 4.0. Okay, so here is the Mini Profiler package class. And this defines pre-start and post-start methods. And so that's what's actually being called here. This pre-start is going to be called here before application start. And then this post-start is going to be called after application startup. Okay, so here's the methods that define pre-start and post-start. Okay, so as you can see, there's a lot of configuration code. There's a lot of things that are commented out. If you're not going to use some of the more advanced, complex features of Mini Profiler, you can leave all of those commented out. But if you're going to use different features, for example, to hook into Entity Framework, you can uncomment things in order to implement different features. Okay, but for our purposes, what's interesting here is this line of code that registers the module. You can either include the definition of the module or activate the module within web.config, or you can use this dynamic module utility and the register module method in order to register this as an HTTP module. So that's the important thing for our purposes that pre-start does. Okay, then there's various other options in pre-start, and there's post-start. The most important thing here is that post-start lets Mini Profiler hook into the current MVC view engine to let it profile both regular and partial views. Okay, so that's what that code is doing. All right, then the last important part here is the actual HTTP module. So it's called Mini Profiler Startup Module. So you saw that referenced in that code within pre-start. And it has to implement iHTTP module, which means that it has to implement init and dispose. Okay, so what this code does within the init is it defines a method that is going to execute in begin request, that HTTP application event. And so what it does is it defines this request variable, gets access to that request object, checks to make sure that the request is local. So this is a way of making sure that Mini Profiler is only available when you're running the application on the local machine. In this case, I'm running this on my development machine, and so isLocal is going to be true. And that's going to start up Mini Profiler. But if I deploy this code to a production machine and access it remotely, then isLocal is going to be false, and Mini Profiler never starts up, and the user doesn't see this information. Another really nice feature of Mini Profiler, so you can include the instrumentation code, but it's not activated. It doesn't do anything if the user is accessing it remotely. Now, you don't have to include this code. You can change that so that everyone can see Mini Profiler, but that's something that you're not really going to want to do very often. Okay, as you can see, there's also some commented out code. that lets you control who sees the profiling information. And then you can wire up the end request event and stop the mini profiler. And I don't need to check to see if this is local or not, because if the mini profiler is not running, this line of code doesn't do anything. All right, in this case, nothing special is required to dispose this class. But because we're implementing the iHTTP module interface, need to include it, but as you can see, it doesn't do anything. Okay, so as you can see, there's a lot here, but most of this code is the implementation of the mini profiler itself, as opposed to the HTTP module. All of the code that you see on the screen now, which as you can see about a third of it is commented out, this is the HTTP module that does some pretty amazing things. And of course, it's built on all of the code implemented within Mini Profiler, which is, again, a very sweet but a pretty comprehensive and complex piece of programming work. All right, so the HTTP module starts the whole thing up, and that's why we need to implement these within begin request and end request. And this code shows how you can hook into application events. You just as easily could have added code to those events in global.asax, as I mentioned, but here it's contained in a single reusable class. And with the isLocalCheck, you don't have to worry about remote users being able to see the profile information.